Good evening, friends. Myself, Dr. M.H. Chennaya, and in this video, we are going to draw the development of a right circular cone whose dimensions are given as the base 50 mm and the end, one of the end generator has got a length of 100 mm. They are not given us the height. I will tell you how to find out the height of this cone. It is cut by a section plane which is normal to VP, means it is cut like this. So it is seen as a line in the front view, and we are required to draw uh, what is called the sectional top view, true shape of section, and the draw the development of the larger part. So in this particular problem, we have combined the development along with the section of solids. So in fact, you will be learning solution for two problems. One is on section and the other is on the development. Friends, let's see what's all given in this question. The diameter of the base is 50 mm. That is, this diameter of the cone is 50 mm. I will mark it as 550, 5 indicating the diameter, and this has got a 50 mm diameter. And height they have not given you, but you know this length, that is again 50. One of the end generators measures what is called 100 millimeter. So friends, here you know this point, and we can locate these two end points, draw a vertical line through this, then taking this point as the center and radius equal to 100 millimeter, you just draw an arc. So you will get this point O, the apex of the cone, you call it as O. This is 100 mm as per the problem. This length is 100 and the diameter of the base is 50. Radius is going to be R, we will call, that is equal to 25 mm. So friends, after construction of this figure, you can find out what is the height in case it is required. So friends, now let me mark or name the corners of these generators at the bottom. So just start marking as A, B, C, D, E, F, G and H. O comma O1. O is for the apex and O1 is for the center of the base. So we have marked this. Now let us transfer all these points, that is A, B, C, D, etc. to the front view and just mark like this. A is here. So this is A dash, B dash, H dash, CG, C dash, G dash, DF, D dash, F dash, and this point is E dash, the last one. So these are all the 8 generators we have got. So we have drawn the front view and top view of the cone, and we need to draw now the section plane. It is said in the question that it is cut by a section plane which is normal to VP and parallel to one of the end generators. Friends, this is one generator, O dash A dash. O dash E dash is another end generator. You can take the section plane parallel to this end generator passing through the center of the base. Center of the base is O1. So I am going to mark this section plane passing through this but parallel to one of the end generators. So this line is parallel to this OA. And friends, if you are asked to find out what is the angle made by the section plane with the HP, you can measure this angle with HP. Now friends, after this is being cut, we are left with this portion of the solid. I will show by visible lines. Only the bottom will show, and remaining all will show by thin lines. So this is the part for which we need to draw the development later on. First of all, let us draw this sectional top view. To write the sectional top view, you have to see where all this section plane SS is cutting the solid. Friends, you can see here This O dash E dash is cut here. So you can write a vertical line through that O dash and see it is cutting here. This is one point on the generator OE. Similarly, friends, here the generators OD and OF are cut here. So we will draw one more line parallel to that and we will get these 2 points. So these 2 points are the points on OD and OF. Finally, friends, it is passing through the center of the base, that is passing through C and G. So C is one point, that is it is passing, this is C and the other point is G. Friends, basically we have got 2 points on the base, 2 on this generator and 1 on this. Totally 5 points we have got, friends. Now after getting these points, friends, you have to join all these by a smooth continuous curve. So friends, we will join all these by a smooth continuous curve. And you can see here, this portion if you hatch, the portion outside this is removed and we have to darken this part of the base. Friends, this figure in the top view will represent what is called the sectional top view. So I will call this as sectional top view, SPV. This will give you front view, and if you want to measure the angle made by the section plane with HP, that can be measured between these two lines. So sectional top view you have got, and we want the true shape of the section, friends. True shape of the section is the mirror image where this is being cut here. So friends, that true shape is going to be a figure similar to this, and you can draw this to the right side of this because this is retained and we are going to hold the mirror parallel to SS, and we can draw this true shape of the section by writing another line parallel to SS and transferring all these points, that is on the base, and all these perpendicular to this. So friends, we are going to just draw these lines perpendicular to that all these lines are perpendicular. On this we are going to mark these points. So I am writing perpendicular through all these points. There is 5 points. And again here you got a point. Point there, that parallel to that we have written. Perpendicular lines are drawn here. Perpendicular. Then this is perpendicular. Perpendicular through this. Not this one. This is the line we have got. And same way you can have one more line here passing through this. So friends, here let us see the distances of all these points. Since there is no space, I am going to show this point. So this is on exactly at G. So friends, you can have it exactly at G means here. This is one point. The extreme point is this one. This is at what distance from here? From here, it is at a distance of so much. So we have to take the distance. And similarly, this point is little interior. So we are going to have another point at the same. These two will be at the same distance. These are the maximum distance. And friends, you have got all these 5 points, and we can just join them by a smooth curve. These points are to be joined by a smooth curve, and this has to be hashed again, and this will give you, friends, the true shape of the section. And in the examination they will ask you to name the true shape of the section. Friends, remember, whenever any right circular cone is cut by a section plane parallel to one of the end generators, the true shape of the section obtained is going to be an ellipse. It is going to be an ellipse. So friends, so we will call this as an ellipse. There is a small mistake here, please excuse. So these points, we have to draw the line parallel to this, that we have done already. There is a small correction here, but it's a nice problem, so we'll go through. We have to draw perpendicular through these. One here, two will come here, and we will have 2 points here. Sorry, there will be a mistake here. Now friends, this point is on C and G. So it is exactly where the point, so this point is G. So this is the highest extreme point, and we will take the distance. This point and this point are to be marked. They are exactly at this point. So this is one point and this is the second point, friends. That is the distance of, this is one point, this is the second point. See, this point is this. This is no, when you are drawing this section, we are going to have this here. So one point you are going to get at this distance, sorry, this distance. Then this gap is going to be 50 millimeter because there is a diameter. I will call or show it as 50 mm. Then on this you have got 2 points, the distance of these two. So friends, on this you are going to get somewhere here these 2 points. Finally on this you are going to get a point. Friends, join all these points so obtained by a smooth continuous curve. And this is going to be the true shape of the section, and this is TS, and this TS is named as parabola. Parabola. So whenever any cone is cut by a section plane parallel to one of the end generators, the true shape of the section obtained is called parabola. Similarly, if it is cut by a section plane perpendicular to both HP and BP or parallel to the axis, the true shape you obtain in the end view, and that is called as hyperbola. And if it is cut anywhere between the top and the base parallel or at an angle to the axis, we are going to get an ellipse. So these three things you should remember, and if there is a question on this, they are certainly going to ask you the name of the true shape of the section. Now friends, we have completed this true shape we have done, and we are naming also we have done. Draw the development of the larger part, that is the second part of the question, which I am going to show here. So we are required to draw the development of the larger part. Which is larger part here. So when this is cut like this, we want to draw the development of this part. So friends, let's see how to draw. To draw the development of this, friends, you have to know the angle theta, then length of the generator. That is the true length of the generator. So the angle theta, the included angle, is given by the formula R by R into 360. Friend, R is given to be, this is diameter 50, radius is 25, and the length of this lamp generator is specified in the problem as 100 mm multiplied by 360 is going to work out as 90 degrees, because this is 25 by 4 is 1 by 4 into 360 is 90 degree. So friends, to draw the development, I am going to write a line here, a vertical line of length is equal to 100 mm, which is nothing but our R, and I mark this point as O. Now taking O R at this point, I am going to construct an angle that is exactly 90 degree. So then we are going to complete that sector which has got an included angle of 90 degree. Friend, this 90 degree is to be divided into 8 equal parts, because the base of the circle is divided into 8 equal parts. Now I will just mark them here, 2 parts, 4 parts, and in between 1, 2, 3, 4. So it is divided into 8 equal parts. We will join all these by thin lines. There should be only a construction line I am showing by thin line, 4, 5, 6, 7 and 8. So 8 we have got, friends. Now we can draw the development of this commencing from OA or OE. Just for a change, let me start with OE. So I am going to mark E here. This is generator OE. Then you have got F, G, H. Then again continue A, B, C, D. This is how we should mark, friends. After marking this, let us see where all the solid is being cut by the section plane. Friends, if you see the bottommost point, the section plane is passing through C and G. So C is one point, G is another point. So you have got 2 points for the base. So I should get points on OD and OF. OD and OF are cut here, but this is not the true length. Hence, transfer that point to the true length generator. Mark the distance on OD and OF. On OD and OF. So, we are going to be sufficiently higher. OD and OF, you are going to mark these distances. Then, friends, what else you have got? It is cutting the last generator OE is over. We made a mistake. OE should have taken first. First is OE. OE. OE at the same distance. The first point. Sorry, OE should be highest point. Okay. After this OE, then this point is OD and OF. OD and OF should be little low. OD and OF. Say like this. And then, friends, we have got here. So totally we have got 5 points. 2 on the base. These 2 points on the base. And then 2 here on generators OD and OF. On OD you have got a point. On OF you have got a point. And then last is on OE. So friends, we have got these points, and you know very well, for the cylinders and cones, the points so obtained either in section of cone or cylinder or in the development, they have to be joined by a smooth continuous curve. So friends, I am going to join this like this, and again this side I am going to join it. And here after that, friends, from CG up to A, the portion is retained. So I am going to darken this part. And here this last portion is removed. Portion on OE up to here, it is retained. So I am going to show that portion retained also by dark line. So we have got all these, friends. Now after obtaining these points, this is how you obtain, friends. And since there is no place to mark, I will leave. If you want, can mark like this: 1, 2, 3, 4, 5, 1. So this first and last are going to be 1, 1. Then this is going to be 2.3, 0.4, 0.5. These are the, because we got 5 points on this. And this is how we should mark the development. And all these construction lines are to be retained. They also carry mark in the exam, including these lines. But remember, friends, whatever the construction lines are to be retained, and your drawing should be very neat, and there should not be lot of overwriting on the line, etc. And friends, this is how we have constructed the cone resting on its base and HP. We have got the sectional top view, the front view, true shape of the section. We named the true shape as a parabola because the section plane is parallel to the end generator. And also I have told you, if it is parallel to the axis and perpendicular to both HP and VP, in that case you are going to get the true shape in the end view, and that is called as hyperbola. And if it is cut by any section plane between the apex and the base like this, we call the true shape as ellipse. Friends, I hope that the presentation was interesting, and if you like this video, please share the video with all your friends. And this is Dr. M. H. Channaya signing off.